this is the advanced distributed system for the final year project on anarchic manufacturing systems. This system here has 5 machine tools, 2 of capability A, 2 of B, 2 of A and B. The jobs on creation appear in the waiting area, and they negotiate with the machine tools so that it can be allocated. So jobs can only communicate with jobs or machine tools within its radius. These circles here denote the radius of which the jobs can connect to that machine tool. So the jobs that can't connect with machine tools or cannot negotiate with them because their cost is too high are brown. As you can see, they move around into another random location in case for that different location and time the machine tool cost they can negotiate, or its own job costs have its own job risk factor and allocation, which I'll go into later, have increased sufficiently so that it can negotiate with the machine tool. So the negotiation is handled by the order handler. So we'll just pause it here. The order handler handles the negotiation on behalf of the jobs, and it collects the variables so that the job threshold it has for that operation, which the machine tool cost must be below, and then it asks for the machine tool to bid, evaluates these bids, and if it's sufficiently low it will get allocated. If the bid is too high, a rebid up to 5 rounds, and if 5 rounds have passed and it cannot be allocated, the job goes back into the waiting area and then moves around again until it can find another machine tool that it can negotiate with. So the machine tools calculate their costs. There are 2 costs for an operation on the machine tool. The main one is an operational cost. Here it's currently at 97, which is quite high because this is based on the machine tool utilization, very high utilization denoting a high operational cost. There are also an emission cost, which is static to start with for each round, which reflects the CO2 the CO2 emissions cost. The machine tool between bidding rounds will reduce its cost to try and win that bid, and this is based on a bid success. So the bid success here is just over 50%, which means that the reductions that are here are 3 and 0.167 for relative to budgets. Machine tools are evaluated once they've submitted their bid. They're evaluated on the best overall opportunity for the job. This is based on the combined cost, which is the cost of the operational cost, the mission cost, plus the factor on waiting time. So this is on the queue length. So here there are 3 in its queue, and times 3 times the average waiting time. So the average duration of 3 operations that's then. So this reflects the environment cost, which I'll go into when we go to the jobs. So these 3 are added together to create combined cost, and the lowest combined cost is taken for the machine tools that have bidded for that job, and then this is evaluated using the order handler to see if that bid is low enough for the job itself. So the jobs is color coordinated as well, so that when they are created, they arrive, they get allocated a budget, so they get 3 budgets. So I'll go on to a job with more operations to do. So this one has 4 operations required and it's completed 2, so it's got 2 more to do. So here it would have evaluated its operations, see how much currency it has during the intro for the order handler, and if it's been allocated, it will then move to the machine tool, queue, operate, and then evaluate how many operations left to do. If it's got more, it will then return to the waiting area and rejoin the scenario, rejoin the order handler and waiting as well. And if it's completed all its operations, it turns purple and moves towards the ship area to exit the system. Here, if there's a machine tool failure, it will move away from this area of the state chart and move back into the waiting area. So the jobs on negotiation have three budgets: operations budget, emissions, and environment, to which they are allocated at the start. They foresee how many operations required in the future. So here it's 4 minus 2, so it's got 2 left. So it will divide its budget divided by 2 to give an allocation for the current operation it's required. So it's got 66, 34, 25 for the environment. So environment cost reflects time in the system to pursue lean principles of reducing working process. So for every second that elapses, 1 second is deducted from the environment budget. So this allocation reflects how desperate it will become until it needs to be allocated to a machine tool. So this reflects the risk factor, which increments the job threshold in bidding, but we'll get on to that in a moment. So this allocation for the next operation is used for the thresholds on negotiation, and between bidding rounds, so this threshold increases by the risk factor. The risk factor is based on the environment, allocation, and excess. So the excess is calculated by each of these allocations minus the expected cost of the operation. So this is done by seeing the previous 100 operations or jobs that have been allocated to the machine tools and taking the average cost of them. So here the average cost is 71 and then 42 for the emissions cost. So this is deducted from the allocation and gives the excess. So it actually expected the excess to be higher, so therefore there's a negative excess for operations and so on, and then there's a very high negative environment excess. So this environment excess, if it is very high and positive, it will mean that it can spend a lot more time in the system, so therefore it can look around for the best opportunity, a lower cost machine tool, therefore have a low risk factor. So it won't increase its job threshold, the threshold for its operation and emissions budget by that much in negotiation and bidding. Rather here it's negative, so it has 1.1, which is quite high, and in the 5 rounds of bidding it will increase it by 1.6 times. So there's the negotiation. Also, if the jobs have been waiting for a stated period, here 3 seconds for an inter-job exchange or 23 for an add currency, they will go into these flowchart areas, and for the add currency we'll just add a certain amount, so quite a reasonably low amount. So it's budget to try and find, to give it more budget to go into a machine tool and be allocated. So inter-job exchanges, this exchanges between jobs, and this is based on the excess it has. So this excess, as I said earlier, is based on the allocation and then the expected cost of the next operation. So if a job were to go into the inter-job exchange, it will try and communicate with jobs within its connection radius, being 150 pixels or however much it is. And then for these, it will then evaluate the balances. So its own balance it will calculate, and this is the amount of excess of operations relative to the amount of excess for emissions. So here is calculated to be minus 10.6, because roughly the operations cost is twice as much as the emissions and environment. The balances are evaluated, and the trading done between jobs is done with two emissions or environment budgets to 1 operations. So these reflect them, and balance is evaluated, and then so this is a negative value. It will then search through all the jobs it's connected with for the largest positive balance, and with that job it will trade so that the balance of operations, so emissions for both of them is reduced, and one of them will be zero, so it doesn't detriment the other, and it will benefit the one with the largest balance, absolute value of the balance, so it has a lot more of one currency relative to the other. So these inter-job exchanges will increase the flow of money between jobs and create a more efficient system. So if we continue running, you see that the jobs are being allocated as before, and if we speed it up, we'll see a machine tool failure as well. And you'll see the utilization increase, although it's already quite high, and there'll be an allocation of jobs. Well, the jobs will move away from the failed machine tool, so I'm going to call this machine tool to fail in a moment, and then we'll move into the waiting area and try and negotiate with others. You see here the jobs are moving around randomly inside because it doesn't have enough currency, or the machine tools are too expensive.